In this session, we will learn how to use ECS Service to ensure our desired number of tasks are running at all times. So far, we have seen how to run task definition as a single task. If the task is stopped, our system is unavailable, unless someone starts another task manually. This is not optimal. You can use an Amazon ECS service to run and maintain a specified number of instances of a task definition simultaneously in an Amazon ECS cluster. If one of your tasks fails or stops, the Amazon ECS Service Scheduler launches another instance of your task definition to replace it. This helps maintain your desired number of tasks in the service. ECS Fargate uses replica scheduling strategy. This strategy places and maintains the desired number of tasks in your cluster with best possible effort to maintain a balance across availability zones. You don't need to specify task placement strategies or constraints. The service scheduler ensures that the scheduling strategy that you specify is followed. The service scheduler includes logic that throttles how often tasks are restarted if a task repeatedly fails to start. If a task is stopped without entering a running state, the service scheduler starts to slow down the launch attempts and sends out a service event message. This behavior prevents unnecessary resources from being used for failed tasks before you can resolve the issue. You can optionally specify a deployment configuration for your service. A deployment is initiated by updating the task definition of a service. During a deployment, the service scheduler uses minimum healthy %, which specifies the lowest percentage of healthy tasks that must be maintained during a deployment. For example, if minimum healthy % is set to 50% for a service that normally runs 2 tasks, ECS ensures that at least one task, 50% of the 2, are healthy at all times during the deployment. A maximum % parameter defines the maximum number of tasks that can be run during a deployment, expressed as a percentage of the desired number of tasks. For a service with 2 desired tasks, ECS allows up to 4 tasks to simultaneously run during the deployment. A higher maximum % allows for faster deployments, as more new tasks can be started above the desired count, but it may temporarily require more resources. To stop a deployment in cases where tasks fail to start, you should enable deployment circuit breaker. Additionally, if you want the system to automatically revert to the most recent successful deployment state when the deployment circuit breaker triggers a failure, you should enable the rollback on failure option. In order to run our task definition as a service, let's go to our ECS cluster again. Under Services tab, you will notice that there are no services currently running. We can create a new service by clicking on the Create button. This will open a Create Service window where we can specify compute configuration. In this lab, we will focus on launch type and select Fargate as our capacity provider. For platform, we will select latest. Under deployment configuration, we select service as application type and specify the task definition and its version. Give our service a name. Fargate only supports replica service type, which is selected by default. For now, we can set our desired tasks as 1. Under deployment type, we can select rolling update and specify the min and max running tasks as %. Under deployment failure detection, it is recommended to select deployment circuit breaker and automatic rollback on failures. Then we can select our VPC and subnets where tasks should be launched. Select a security group for traffic control and click Create. This will create our service and launch the desired number of tasks specified in the service. When we click on our newly created service, under Tasks tab, we will see that the service scheduler has started a task that is being provisioned. After a while, when the task status changes to running, we can get its IP address and open it in our browser. There you have it. Our web server is now running as a service. Let's go ahead and stop the task now. The scheduler will detect that the task has been stopped, whereas the desired state is one task. So it will try to launch another task automatically. We can verify this by reviewing all the tasks. One thing to note is that the new task will have a different IP address. So our web server will not respond to the original IP address. This is clearly not desirable. In the next video, we will see how to fix this issue. Thanks for watching.